Okay, yeah, hi everyone. Yeah, let's stay together to solve the uh, some selected problems of the chapter 12 is the quadrilaterals. So the first question is 203. Prove that if a quadrilateral is orthodiagonal, then the midpoint of its sides the vertex of a rectangle. Okay, so let's draw any quadrilaterals. That's A, B, C, D, and what we know is the BD and AC are orthogonal to each other. Then we take the midpoint, see the EF GH. Okay, so if you know it's the EFGH, right? And we know the EF and the HG, right? So in triangle ABD, the EF is the two midpoint connections. So we have the EF parallel and equal to the BD, right? And the same thing, we have GH parallel and equal to the BD. Okay, and if you take a see another two lines, we have the ADC, right? We have the EH is parallel and equal to half. Okay, the half of the AC, and the FG is parallel and equal to half of the AC. Okay, so now we know this is a parallelogram, right? If this is a parallelogram and the EH is parallel to AC and the EF is parallel to BD, so this must be also 90 degrees. So we have a parallelogram EFGH, parallelogram. Okay, and EF, EH. So now you can see this is the rectangle. Okay, so this is the very important results. So what I want to say is for any quadrilaterals, if you take the midpoint on the four sides, okay, and it will be a parallelogram. 209. So prove that if connecting in order the midpoint of sides of any quadrilaterals, a parallelogram is formed. So this is the same thing, right? Like what we just talked about it. So A, B, C, D. And for any quadrilaterals, if you take the midpoint, right, it's the E, F, G, H, right? And we only need to connect these two lines. Okay, so we have the GH parallel and equal to half of the AC, and the EF parallel to equal to half of the AC. Based on these two, right, GH equal to EF, and GH also GH parallel equal to EF. Then you can see the EFGH is parallelogram. Okay. Next question is 210. Okay. So for problem 210, we have a square is ABCD. Let me draw a big picture. Okay, so we have the A, B, C, D. Okay, and then AB equals 1, right? And we connect it here. Then we know the EFGH is also a square, right? So we draw this, and it's also a square. So now let's see, okay? So this is the AC, right? You know this is the center. Let's see, this is the M. Then what we can see, let's assume this is the X, right? So this will be the X, and this will be the 1 minus X, because I mean the size is the 1, right? So it's 1 over root 2, then this one is 1 over root 2, right? So we have a triangle. We have a similar triangle, right? So we have the triangle B. Let me see. It's EH. Okay. So we have triangle BEH is similar to triangle BCM. Okay, from these two triangles, you know 1 minus x over 1 is x over 1 over root 2. Then you can see it is the root 2 plus 1 of the x is equal to 1, right? So now you can solve the x equal to root 2 minus 1, and then the area of the EFGH is the x squared is equal to 3 minus 2 root 2. Okay, then question 211. So we want to prove if a quadrilateral ABCD is orthodiagonal. Okay, so this is also another important result. That's why I want to put it here. Okay. So if A, B, C, D, okay, the diagonal are orthogonal to each other, okay, then what we have is the AD square plus the BC square is equal to AB square plus CD square, okay. So the square of the two opposite sides equal to the square of the two opposite sides. So when we prove this, it's very simple. We can see this is the PQRS. Okay, so you can see the AD square plus the BC square based on the Pythagorean theorem. The BC square is P square plus Q square, right? And the AD square is S square plus the R square, right? Okay, so you can see you can prove on the other side. This is very important for this symmetry because I remember there is a AMI problem. You will use this technique. Prove that if 212, if trapezoid ABCD is orthodiagonal. Okay, so we have a trapezoid. Okay, then we have the ABCD, and if they are orthodiagonal, so these are orthogonal, right? We want to prove the AC square plus BD square, right? So you can see the AC square plus BD square here. You cannot add them together, right? So, but it gives us, if we want to use the AC square and BD square, how about we need to extend in the BD here, right? Make a parallelogram. So because this is already parallel to this, right? We extending this, then we do the CE parallel to BD. Then we can see the BECD is a parallelogram, right? BCD is a parallelogram to, we know the CE is parallel and equal to BD, right? So now you can see if AC is P, BD is Q, then this one is Q, then the AC square plus the BD square is equal to P square plus the Q square is equal to AB plus BE of the square, right? Because this also is 90 degrees. Okay, then you can see it's AB plus CD of the square. Yeah. In order to make the cross lines and when the metric of those lines adding together, okay, and they are orthogonal, we're always trying to move them into a triangle than to use these conditions. And the next problem is 213. So we have we have a trapezoid, and the AB and the CD are parallel. So we have a trapezoid. Okay, we have the A, B, C, D. Then we have one is A, the other one is, sorry, this side is B, the other side is A. Then we know the measure of the angle B is twice of the measure of the angle D. So let's say this angle is alpha, right? This angle is 2 alpha. So now let's do an angle bisector, right? Since we do an angle bisector, let's see, okay? Is parallel, let's see, this is E, right? By angle bisector, this is alpha, right? And the AB and the CD are parallel, right? So by the interior alternating angle, so this angle is alpha. And you can see if this angle is alpha, right? So we have the AD and the BE alpha, and the cutting line is DE. That means we prove the AD is parallel to BE, right? And also AB is parallel to DE, right? So you see the ABED is a parallelogram. Okay. Then we want to find CD, right? Okay, so you can see this is the alpha and this is the alpha, right? So triangle BCE is an isosceles triangle. That means the EC equals BC equals A, right? So this is the A, and this is a parallelogram, this is the B, so CD is equals to A plus B. Okay, so question number 214, okay. Question number 214, let's duplicate a big picture, okay. So we have a rectangle ABCD. Then we have the two diagonals BDAC. Okay, so the center they intersect at the E. Then the P is any point here. So we land the P of S is perpendicular to BD. Then we land the AF is perpendicular to BD. Then we land the PR. We land the PR is perpendicular to AC. We land the PQ is perpendicular to AF, and then the crossing point is T, okay? So what we want to see, okay, so PR plus PS, okay, is equal to which metric? So let's see the PR and the PS, okay? So PR is here and PS is here. So PR is here and the PS is here, okay? So now let's see. If you notice, okay? If you notice, okay, let's connect in the PE, okay? Let's connect in the PE, okay? So let's assume that the AE equals BE equals DE equals CE equals A, okay? Then you can see the PR, right? So half of the A times the PR is of the triangle APE, and the half of the A times the PS is half of the triangle PEB. So then you add them together, right? So the PR plus PS and the half of the A is equal to triangle AEB is 1/4 of the area of the ABCD. Okay, so now for the rest of the metric, we want to see half of the something is equal to 1/4 of the metric, right? Now let's see the PQ. Okay, let's see the AE. Let's see the half of the AE times AE square. No, right? AE is A, right? Is A, right? Half of the A times is half of the A times A, right? It doesn't work. So AE no, PQ no. And how about the PT plus the AT? No. See AF, half of the A times the AF is this triangle, right? Yeah, it's equal to triangle AED, so it's equal to a quarter of the ABCD. Okay, so that's why the AF is the right answer. Okay, so question number 215. So let ABCD be a parallelogram of area 10. Okay, so let's draw a parallelogram of area 10. Okay, then we have the ABCD. So AB is 3, BC is 5, then EFG are on segment of the AB, BC, and the AD, and respectively we have the AE equals BF. AE is 2, so it's 2 and 1, and the BF is 2, so BF is 2 and this is 3. The AG is 2. So these are parallel and they are all equal. So so AGFB is also a parallelogram. Okay, AGFB is also a parallelogram. Then the line through the G parallel to EF. Okay, so this is the EF, and the line through the G parallel to EF intersect the CH at H. We want to find the area of quadrilateral is EFGH. Okay, so in order to find the quadrilateral of EFGH, right? So you can see this one is parallel to this one, right? So it's a trapezoid, but maybe the easiest way for us to solve is to use the parallelogram we know is 10 and take out the rest of the area, right? So now let's do the height, right? H equal. So we know the parallelogram is 5 times the H equals 10. So we have the H equals 2. So this one equals 2. Now if they know this one equals 2, right? Then we can do this one. So you can see, okay, so this the height is cutting into the 1 and 2, right? So this is the 2, means the 2 is cutting into 3 pieces, 2/3 this height, and the 4/3 is this height, right? So now we can calculating the BEF is half of the 2 times 2/3 triangle. The AEG is half of the 2 times 4/3. All right, and we need this triangle, right? So this is 3, so we need the S of the GDH plus S of the FCH, right? Is half of the 3 times the H1, right? Plus H2 is h is half of the 3 times 2, so this part is 3, right? And this two part together will be the 2, right? So you can see that you can know the EFHG is equals to 10 minus 2 minus 3 equals to 5. Okay. Then question number 217. Okay, so we have E is a point intersection of the diagonal of a convex. So we just have any convex of the quadrilateral A, B, C, D, right? Okay, let's see. This one is the A, B, C, and D. Okay, then the P, Q, R, S are the center. Okay, of we have the diagonal. Okay, E is the intersect. E is the intersection point. Okay, so E is the intersection point, and this is the quadrilateral. So we have the ABE, right? ABE, BCE, CDE, and ADE. Okay, we have the circumcenter of these 4 points, right? So how to you need to remind you how to do the circumcenter, right? The circumcenter is the intersection of the 3 perpendicular bisectors, right? That means the perpendicular bisector, did you see they have the common perpendicular bisector? This perpendicular bisector, okay, can help you to define the point of the P and the last point of the S, right? And this perpendicular bisector, let's do some perpendicular bisector, right? Okay, perpendicular bisector, right? The perpendicular bisector. Okay, now you can see for this perpendicular bisector, right? So this how we define the P, Q, and R and S, right? What does the perpendicular bisector mean? Perpendicular bisector means 90 degrees, 90 degrees, right? And 90 degrees and 90 degrees, okay? So now what you can see is RQ is perpendicular to AC and the PS is perpendicular to AC. You must know RQ is parallel to PS, right? And similarly, you can see the RS is parallel to PQ. Then this is the parallelogram, right? Yeah, so that's it for the selected problem of this chapter. Okay, thank you. Bye-bye.